Good morning and welcome back to this coding tutorial, which is following along with the University of Helsinki's massive open online course. My name's Duncan and I will hopefully be making the mistakes for you and giving you a few hints and tips on how we can complete these tasks, and hopefully as well explain a little bit more of what's going on. So last time we completed up to from where to where, which was the first of the two-part challenges. So that's just up here a further bit. There we go, that one. So now we are on sum of a sequence. So we'll get straight on with that. So we have to implement a program which calculates the sum 1 plus 2 plus 3 all the way up to n, where n is given as user input. Okay. So last number 3, the sum is 6. Obviously 3 plus 2 plus 1 is 6. The previous example calculated, there we go, that. And then this one is an example of 7. So we are going to need to open our NetBeans. Let's close this one down. Let's open our sum of sequence project. There we are. I'm going to quickly whiz back to the class here and pinch this just so we've got the outputs. And let's get going. So the first thing that we're probably going to need is a user prompt. So we're going to need to let our user know what to do. In some of the previous examples we looked at examples where they didn't have a prompt, and it was a bit confusing in the console to know when the application was running and when you're meant to input and wait, sort of thing. So right, let's just put these in there as comments. So we need this as our first prompt. Okay, so last number, and then we're going to need to store that number in an integer. What's going on there? So int, we'll call it ln for last number. ln, there we go. And we're going to say that that's equal to scanner.nextInt. Okay, so we've got that, that's great. I'm just going to change that. There we go. And now we're going to need a loop. So I'm going to use a for loop initially, and then we'll see if we can figure it out with a while loop as well. So we're going to say for int I equals ln, I less than, right, okay. So I'm going to have I is 0, and while I is less than ln, less than and equal to, sorry, we're going to I plus plus, and then in the body of the loop we are going to, let's see what we need to print out. I think it's just the total, isn't it? Last number, okay, that's fine. So we're going to need to do a addition. So we've got, so what we'll do is while I is less than or equal to ln, we will do I plus plus, like that. And then, do you know what, actually I think we're going to need a couple of variables so that we can take one as an input and then store one as a sum. So let's get another variable in here. I'm going to put it up top here. So int sum equals 0. There we go. So we're going to do I plus plus. But before that, we're going to do sum plus equals I. So we've got our for loop. And inside the for loop we're saying that while I is less than or equal to the user input, we're going to add the value of I all the way up to until I equals the user input, and we're going to add one. Actually, we don't need to add one, do we? Because we've got I plus plus here. So let's just quickly sort this out, get rid of these comments, and then we'll test it locally. So we'll do a system out, and then, oh, what was the system out? Just deleted it. The sum is, okay, sum is, and then we need our concatenation, don't we, which is the plus, and we will be plussing or concatenating sum. So let's give that a whirl. We know that if the input is 3, it should equal 6, and we know that if it's 7, it should equal 28, I think it is. So we can give it a quick test, make sure it works as we expect, and then we can submit it. Okay, it's passed, but I've got a warning, and that's because my integer here didn't actually follow, or doesn't follow, the normal naming conventions. So I've selected the 2 letters, and I'm going to press Ctrl and R on my keyboard. The other way you can do it is right click and go to refactor and then rename. And I'm just going to change that lowercase l, the uppercase L to a lowercase. And the good thing is that it does it throughout your entire project. So let's give that a run and see what happens. And there we go, we're off to a great start. So let's OK that and close this project down now. Oh, the amount of projects I close, I should be able to go to it through like muscle memory or something. Oh, do you know what? I'll open it back up again and see if we can do the while loop version as well. So if there's anyone working on a while loop, we can do that. So the while loop and for loops have the same sort of criteria, the same conditions and the same bits of information that make up the while loop. It's just in a slightly different format. So I'm sure we can work this out. So while, so we can say ln, actually, yeah, so ln is less than or equal to 0 and then we can do sum plus equals an I. So what we could do here is change this 0 for a count or an I. So let's say comma count equals 0, and we can change that 0 to count, and we can change this to count as well. So sum plus equals count, and then when that's finished we can system out this. Actually, I should have just copied that, shouldn't I? So we'll just copy that. There we go. So I'm going to comment out this top section of code. So I'm selecting it all and pressing Ctrl and /, and then we can run this locally using the same tests that we used before. So, okay. So that didn't work. So sum plus equals count. Oh, because we haven't increased count. So we need to do count plus plus. So that's the good thing about a for loop, is that it increments for you. It's something you need to remember with a while loop. I'm just going to turn my mouse sensitivity down. There we go. So let's do 3. Sum plus equals count, count plus plus. That says greater than. There we go. Run it once more, try 7, which I think was 28. There we go. Excellent. So we've got the while loop version and the for version as well. So let's close this one down. And we're going to head back here, refresh to make sure we've got our points. And then sum of a sequence, the sequel. So implement a program which calculates the sum of a closed interval and prints it. Expect the user to write the smaller number first and then the larger number. You can base your solution on this exercise to the solution of the last exercise. Add functionality for the user to enter the starting point as well. Okay, that's great. So let's copy this so I remember my prompts. Let's open up this class. And I'll paste those in, comment them out. Okay, so we're going to need a couple of variables. So we're going to need, if we're going to do both examples, we're going to need one for the sum, and then when we do the while loop version, we're going to need one for the count, potentially. So let's do the for loop first. So we are going to need user inputs, 2 user inputs. So lower number and upper number or higher number. Okay, and we're going to need some prompts. So system out, so first number. Oops. And then we can update our integer here to say that int lower number is equal to scanner.next int, like that. I'll leave this one like it is. I'll move it to the top like that, and I can't remember if I've shown you this before, but probably good to keep doing things with different examples, so it's sort of repetition makes it stick, sort of thing, doesn't it? So upper number is equal to scanner.nextInt. There we are. So these two lines are basically the same, but we've split the declaration and assignment of this one. Okay, so this one's got declaration, so int declaration and assignment in the same line, or on the same line, sorry. Okay, so now we need our for loop, and we can say int, so I'm going to say int I is equal to lower number, and then what we're going to say is that while the upper number is greater than the lower number, or lower number is lower than the higher number, we're going to run through the loop very similar to what we did before, and then we're going to increment the lower number, or I, until they're equal. So upper number is, actually let's do lower number first. Lower number is less than or equal to upper number, lower number plus plus, and then, so, oh, I forgot to do the sum variable, didn't I? So comma sum equals 0, there we go, and then we can do sum plus equals lower number, oops, and then we can do our system out, which is that sum is plus sum, and I forgot to put the second prompt in there, so we need another system out here, so s out last number. Let's give it a test locally, see how we do. So 1 and 3, 6, that's great. And then we'll test it again with 1 and 7 and make sure we get 28. Perfect. So let's give that a send off and see how it goes. And we've got ourselves a little pass. So let's do that. And then we can do the while loop version as well. Okay, so let's do this while loop. What we'll do is I'll comment out here. So then we've got the same prompts, we've got the same outputs as well, and it's just the while loop that we need to change. And the good thing is we don't need really a counter this time because we've got a lower and an upper limit anyway. So while lower number is less than or equal to upper number, we'll do sum plus equals lower number, and then lower number plus plus. So the lower number plus plus is incrementing the lower number until it is equal to upper number, and that's when it will stop our loop. So let's give that a little run, and we'll do 1 and 3 and 1 and 7 again. So 1 and 3, 6, perfect, and then 1 and 7, 28, excellent, so we've got that one as well. Just again, if you're wondering how I ran it from without using the button up here, it's F6 on your keyboard, and that will run the main of the projects that you're in. Okay, so let's refresh this. Factorial. Okay, so implement a program which calculates the factorial of a number given by the user. Factorial of n is denoted as n with an exclamation mark is calculated as 1 times 2 times 3, etc. For example, the factorial of 4 is 1 times 2 times 3 times 4 equals 24. Additionally, it has been specified that the factorial of 0 is 1. So 0 factorial equals 1. Okay, let's pinch this. Let's open Factorial. Oops. Paste those in, and we can start with our data types, our integers. In fact, we'll start with our s out. So give a number. There we are, and then we can do int num equals scanner.nextInt, and then we can start with the for loop again. So for int I equals 0, oops, while I is less than or equal to num I plus, gosh, what am I like, I plus plus, and then we need to do the bit of maths. So we're going to need a sum, int sum. So before we were using sum plus equals, we can actually do times equals. So let's add in sum times equals num. Oh, so I've got an error on my sum here because it needs to be initialized, so we need to give it the initial value of 0. There we are. Let's give that a test. Let's system out this. Oh, I needed those, didn't I? So factorial plus sum, and it's printed on the same line here actually, so let's mix it up a bit. So instead of system.out.println, you've got system.out.print, which will print the output and expect the input on the same line. So give a number, 3, factorial 0. Okay. What we can do is add some tests in. So I is less than or equal to that. So what I'm going to do is put a system out in here and just see what's happening with sum and see if we can get sort of any information about what I've done wrong. So give a number 3. So it's printing out 0 each time. So the sum times equals should be I. Let's try that. So it's still printing out zeros, so we've got, let's change that to 1. I think if I remember rightly, we might need to add a little if statement in as well, mightn't we? Okay, I'm going to go back to the classroom and let's read the brief again. Additionally, it's been specified the factorial of 0 is 1, so 0 factorial equals 1. So I've put some print statements in just to see what the numbers are doing, how they're adding up, where they're adding up, and I've changed our I to 1, and sum obviously I changed to 1 earlier as well. If I just give it a little run now, we can see all of the steps that the code is taking as it goes through the loop. So if we do 3, we can see that I is initially equal to 1, num is equal to 3, sum 1, and then so on and so forth until the factorial actually comes out at 6. So this is what we wanted, and I believe it was because my I was set to 0. I think that was the only thing that I changed, other than adding these lines in, which don't actually have an effect on the code, on the sort of logic of the code. So I'm going to give that a little run and see if that works, and then we'll have a go at putting it in a while loop as well. And we've got ourselves another little pass. Excellent. So let's close this one. Back to here, give our little points a refresh. Okay, so that's the factorial one done. Additional info. Factorials are used especially in probability calculus when examining possible orders of a set. For example, a group of 5 people can form 5 factorial. Different lines and a pack of 52 cards can be in 52 factorial different orders. Factorial can also be used to calculate combinations. For example, it is possible to deal 52 factorial divided by 5 factorial times 52 minus 5 factorial, different hands, a 52 card pack, and you can form 40 factorial divided by 7 factorial times 40 minus 7 factorial, different 7 number lottery lines from 40 numbers. That's a lot of numbers. So on the structure of programs using loops. In the previous examples, we've concentrated on cases where the loop is executed a predetermined number of times. The number of repetitions can be based on user input. In these cases, the for loop is quite handy. In programs where the loop body has to be executed until the user gives a certain input, the for loop is not too great. In these cases, the while true loop we practiced earlier works quite well. Let's take a look at a somewhat more complex program that reads integers from the user. The program handles negative numbers as invalid, and 0 stops the loop. When a user enters 0, the program prints the number of valid numbers, the number of valid numbers, and the number of invalid numbers. A possible solution is detailed below. However, the style of the example is not ideal. So we've got 3 different integers, all set to 0. And while it's true, input is updated. Well, this is a new integer, sorry. So we've got int input. If input equals 0, sum of valid numbers, sum of invalid numbers. I see. Perfect. So it basically just cherry picks and puts the numbers into the appropriate variable. In the code above, the computation executed after the loop has ended is implemented inside the loop. The approach is not recommended as it can easily lead to very complex program structure. If something else, for example, reading more input, is to be done when the loop ends, it could also easily end up being placed inside of the loop as more and more functionality is needed. The program becomes increasingly harder to read. Let's stick to the following loop structure. So, create variables, read input, end loop, check for valid input, handle valid input, and then functionality to execute after the loop ends. So it keeps it nice and simple and straightforward. In other words, the program structure is cleaner if the things to be done after the loop ends are placed outside of it. So it's the same code example, but they've just put the outputs at the bottom, which makes more sense because every time it runs through the loop it's going to print these out, which may not be what we need. So this one's got 5 points. Wow. Cool, okay. Oh, and it's one to end on as well. Excellent. So next we'll implement a program one piece at a time. This is always strongly recommended when coding. The series of exercises form a larger program whose functionality is implemented in small pieces. If you do not finish the whole series, you can still submit the parts you've completed to be checked. This can be done by clicking the submit button, the arrow pointing up, so we know where that is. Although the submission system complains about the tests of unfinished parts, you get points for the parts you have finished. So remember that each subpart of these series is equivalent to 1 individual exercise. As such, the series is equivalent to 5 individual exercises. The tests might fail a correct solution. This is known as a bug. That will be fixed in the future. In the meantime, you can avoid the error by printing give numbers without any spaces after the colon. Implement a program that asks the user for numbers. The program first prints right numbers until the user gives a -1. When the user writes -1, the program prints thanks by and ends. Okay. Just pinch that. Head back here. Oh yeah, right, let's open this one. Let's close that down. So this exercise is worth 5 points, that's fine, we knew that. If you want, you can send this exercise to the server when it's just partially done. In that case, there we go. We knew that as well, didn't we? So I'm going to delete this. There we go. Brill. Right, I'm going to paste in my code here, or not my code, sorry, my prompts. We'll do an S out, fill give numbers. Like that. We're going to need an int input. So int input is equal to scanner.next int. And then what does the code actually do? Implement a program that asks the user for a series number until the user enters -1 and prints thanks by. Okay. Okay, so let me think, what's going to be the best way to do this? So we can use a while loop for this. So while input does not equal -1, we'll keep running this loop. And it seems that the input actually needs to be inside the while loop. Because they're looping through it until the user, so it's expecting inputs. So let's put that there. Let's get rid of this int bit here. We're going to declare it up here. So int input is equal to 0. So we've initialized it, we've given it a value. It's not equal to -1, so it will keep running. We only need to print give numbers once by the looks of it, so that's fine. While input does not equal -1, input equals next. That's fine. Okay, well let's just see what happens with that. So we'll test it with a few different numbers. So 2, 3, 5, -1. And then you can see the code has stopped. That seems a bit too easy. Let's give that a test and see what happens. Well, that's brutal. I didn't print out the system out, did I? The thanks by bit. Let's pinch that. So outside of the loop we need our S out, which is thanks by. Let's try that. Oops. Okay, so we have got a test on part 1. That's great. So let's go back to the code. Not the code, sorry, back to the classroom, and then let's see what we need to do now. So extend the program so that it prints the sum of the numbers, not including the -1, the user has written. Okay, let's go back here. Okay, so we're going to need an S out for sure, and that's going to say sum with a capital set, one of them. We're going to need a sum variable as well. So let's add in sum here. And then we need a value up here, so sum equals 0. And we're going to say if sum, no, hang on, no we're not, we're going to say if input is greater, no, that's less than, greater than 0, we can do sum plus equals input. Oh. And the reason I've done greater than 0 is because we don't want to include the -1, and 0 probably doesn't make any odds anyway, so that shouldn't cause any issues. So let's have a look. Let's do a few numbers. Well, so we've got 2, 5, 9, 14. Cool. Okay, let's give that a test. See what's what. Guys, we're cooking on gas today. Look at that. We've got another one passed. So let's go back to here and see what the next part is. So extend the program so that it also prints the number of numbers, not including the -1, the user has written. So we need a count. That's fine. That's going to be quite nice and easy for us. We've done that before, haven't we? So let's add in a variable up here called count, and we will initialize it to 0. Hang on, let's have a look. Does it include zeros? So it might include zeros. So let's put count plus plus in here. Let's see what the output is. Oh, just numbers. We need that, one of them, and then we need to add our count in. Let's give that a run locally. So let's just do 1, 2, 3, and then -1. Oh. Okay, let's give that a test. Look at that, another one passed. Oh, hang on, did we pass that one? Yes, I think we did. Right, let's go back here. Yeah, we did pass that. So now we need an average. Okay, so this one is using double. So we could multiply the value by 1.0, and then that would convert it to a double. Right, let's go back here. Okay, so let's get this started. So we need the average, which is just that there. So let's take that, and I'm going to work backwards. No real reason other than cursors down the bottom. So I'm going to do plus AVG, and I'm going to say double AVG is equal to, in fact, here, just declare it, and then down here we'll update the value. So we're going to say AVG is equal to count divided by sum. test locally, make sure it works. So I'm just going to flick back here. So they've done 5, 2, 4 and -1. 5, 2, 4, -1 to exit. So the average isn't updating. That's fine, we can get that fixed. So let's see. Okay, so looking at this, I've got I believe I've got this the wrong way around. That should be sum divided by count. And we'll do 1.0 times sum divided by count. Let's try 5, 4 and 2. And -1, 3.66. So that's pretty much exactly what we needed. So let's give that a test to see how we get on. And then we could be on to our final section, which will be quite exciting. So remember, because we're doing the part 5, we've got points by the looks of it awarded for the first part, the second part, the third and the fourth. So all we should have to do now is just this 5th part. So let's close these, head back to the website, and now we need to extend the program so that it prints the number of even and odd numbers excluding the -1. Okay, so we need this on the bottom, so let's copy that. I'm going to wrap that in an S out as well. So that's going to be plus, oh, need my double quote, don't I? Plus even, this one's going to be, why is that not working? Oh, I haven't put my semicolon on there. There we go. And then we're going to need odd plus odd, and what we can do is, we could do a nested if, so an if in an if, and we could say if input does not equal 0, so if input mod 2 does not equal 0, oh, it's all going horribly wrong. So let's put some notes on, so end of greater than 0 if, end of while, oh, end of while, and then this is the end of our nested if. So if input mod 2, which is divide by 2, does not equal 0, then odd plus plus, even plus plus, and, oh, that's because I haven't created the variable yet. So let's do even equals 0, odd equals 0. Then we can do else odd plus plus, because if it doesn't meet this criteria, it must meet this criteria. Right, so let's give this a run locally, so using F6, and I'm going to just quickly, oh, so they've used the same numbers, that's fine. So 5, 4 and 2, then -1, but I've got 1, so I've got them the wrong way around. Oh, of course. So if it does not equal 0, silly me. So if it does equal 0, then that'll be right. So let's give that a test against the server and see how we get on. Okay, so we've got an error. So let's have a look and see what happened. With the input 10, 8, 7, 16, 14, 0, -1, the output should be even 5, expected 5, but got 4. Oh, I wonder if they're counting 0. I don't know how this will affect the rest of the code, but let's try and see if the input is greater than or equal to. I'm just going to test it against the server because I've got no chance of remembering those numbers. There we go, perfect. Excellent, so we've got that one completed as well. There we go, and in just over half an hour too, so that's great. So let's head back here, make sure that all of our points have come through. That's quite satisfying, knowing that we've got 5 points for that. So in the previous exercise, we used a series of exercises to practice implementing a program one piece at a time. When you're writing a program, whether it's an exercise or a personal project, figure out the types of parts the program needs to function and proceed by implementing them one part at a time. Make sure to test the program right after implementing each part. Never try solving the whole problem at once, because that makes running and testing the program in the middle of problem solving process difficult. Start with something easy that you know you can do. When one part works, you can move on to the next. Some of the exercises are already split into parts, however it's often the case in programming that these parts need to be split into even smaller parts. You should almost always run the program after every new line of code. This ensures that the solution is moving in the right direction. So next we're going to be looking at methods, which is going to be really exciting. So we're going to be looking at creating our own blocks of code and calling those blocks of code, or those methods, to be used from potentially the main method. So let's have a quick look and see how we're doing here. So that's looking good. We're over halfway now for our programming exercises. That's great. Just to not reiterate, but just to go back over this implementing one piece of program code at a time. There's actually a word, well, there's quite a bit of a buzzword around breaking down your projects at the moment, called computational thinking. Computational thinking, which I will just quickly show you. There's 4 cornerstones to computational thinking, and one of them is decomposition. And decomposition is basically breaking down a complex problem into smaller problems, and then when you solve each of those small problems at a time, bringing them back together to complete the overall whole, so the sum, if you will. So it might be worth having a look into decomposition, or maybe even computational thinking, just to get a bit of a background idea about it, how it works. It's something that I teach my students. I don't know how widely used it is in industry, but it can give you a different viewpoint of looking at projects. So that might be quite interesting for you to consider. But as always, thank you very much for joining me today, and I hope this was useful for you. I hope I made all the right mistakes, and I will see you hopefully in a few days for another video of around half an hour length. Thanks so much.